Section 10.4, we're looking at inscribed angles and polygons. In the first part of section 10.4, we're looking at inscribed angles, which is another type of angles in circles. What is an inscribed angle? An inscribed angle is an angle whose vertex is on the circle. Okay, the vertex is on the circle. So in this picture, we have an inscribed angle at angle C. Or if I wanted to name it 3 letters, angle SCR. It is an inscribed angle because if you notice that vertex C is actually located on the circle itself, and this is an inscribed angle. And the sides of an inscribed angle are chords of the circle. If you notice, SC is a chord of the circle because its endpoints are on that circle, and CR is another chord, its endpoints are on that circle. So an inscribed angle, vertex has to be on the circle, the sides are chords of that circle, and then we actually have a name as well for the arc in the interior of the inscribed angle. Is called the intercepted arc. Now, interior of the inscribed angle means go from the endpoints of the angle, so S and R. And this arc, SR, is called your intercepted arc. I'm going to be using that term a lot. Your intercepted arc of this inscribed angle. Again, inscribed angle, vertex on that circle. And we got to discover what's the relationship between an inscribed angle measure and its intercepted arc measure. Discovery here. How does the measure of that inscribed angle compare to the measure of its intercepted arc? So I'm going to look at these examples here. I have an inscribed angle at vertex D because its vertex is on the circle. Its intercepted arc would be from C all the way to B. Now, just by looking, well, and I guess we have proof of this. What is the measure of arc CB? Well, if this is a diameter CB because it goes through the center, this is a semicircle. What's the measure of the arc CB? And you should be saying 180 degrees. It's a semicircle. Angle D is definitely not 180 degrees because it's not a straight line. What does the measure of angle D look like? You should be saying that looks a lot like a right angle, and it is. Angle D is 90 degrees. An inscribed angle is 90 and its intercepted arc was 180. I wonder if that relationship will hold for another example. In this example, I'm looking at angle D. It is an inscribed angle, right, because its vertex is on that circle. And I'm looking at the arc that is intercepted. Okay, the intercepted arc would be from the endpoints of that angle, so C to B. Now I want to add something. Just a little bit of a dotted line here just to get a reference point. Now if you look at that, doesn't this look like right angles here? Remember that this would be a central angle, and that looks like 90 degrees. So if the central angle is 90, then this arc is 90. Also, this arc should be 90 degrees because doesn't it look like this arc is half of the semicircle here? So that's 90. Well, this is not 90 degrees. If you think about it, since the radii are congruent here, I have an isosceles right triangle. Remember, this was a right angle here. Isosceles right triangle, and so that has to be 45, 45, 90. Look at the relationship then. A 90-degree inscribed angle, a 180-degree intercepted arc. A 45-degree inscribed angle, vertex on the circle. A 90-degree intercepted arc. Looks like the intercepted arc is double the measure of the inscribed angle, or the inscribed angle is half of the intercepted arc. And that is true always. The measure of an inscribed angle theorem says the measure of an inscribed angle is half the measure of its intercepted arc. So our important statement that we're using for everything today. An inscribed angle, remember if the vertex is on the circle, that angle is half the measure of its intercepted arc. Alright, so in this picture, find the measure of angle D. Angle D is right here. It is an inscribed angle because its vertex is on the circle. Take a look at its intercepted arc here. Its arc is BE. The measure of its intercepted arc is 100 degrees. An inscribed angle is half of that, half of 100, so 50 degrees for angle D. And that looks about 50 degrees, so that looks good. What about the measure of arc AB? Okay, here's arc AB. This is what I'm ultimately trying to find. Well, I don't think I have a way to directly find that. But if we take a step back and we first look at this angle of 35 degrees, this is an inscribed angle, is it not? Vertex B on the circle. And this inscribed angle of 35 has an intercepted arc here of AD. Now, if I have the inscribed angle as 35, the arc should be double that. 35 times 2 is 70 degrees. And now I'm going to use this diameter because I know that this whole arc is a semicircle. And a semicircle is 180 degrees. Therefore, if this is 70, 180 minus 70, this blue arc that I was looking for, arc AB, would have to be 110. So 110 degrees there. Again, inscribed angle was 35. I doubled that to get the intercepted arc, which was 70. And then we had a semicircle, which was 180 total. And 180 minus 70 leaves 110 degrees for arc AB. All right. In this diagram, let's find the measure of arc KN. I'm just going to pause and let's find that measure of arc KN. So that would be this arc here. Well, if you look at the angle of 52 degrees here, oops, I don't want to go there. I'm going to look at this angle. Now 52 degrees was an inscribed angle because L, the vertex, is on the circle. And if that's an inscribed angle and its endpoints are K and N, which is the arc I'm looking for, I know that an inscribed angle to the arc, I would have to double it to find the measure of arc KN. So 52 times 2 would be 104 degrees for arc KN. And next, find the measure of angle KMN. Angle KMN, or angle M, basically. Wait, isn't this another inscribed angle? Angle KMN, because that vertex M is on the circle. Wait, look at the intercepted arc. K and N were the ends of the chords that made that angle, so the intercepted arc is still arc KN, the same one I just found. Now, if the arc is 104 degrees, the inscribed angle should be half of that, so this angle should be 52 degrees, half of 104. And now, what do I notice about angle KMN, which was the one I just found, 52 degrees, and angle KLN, which is the one I was given? Well, they are congruent, right? Why are those angles congruent? Because didn't they have the same intercepted arc? They're both inscribed angles, and they have the same intercepted arc. Therefore, they're going to have to be congruent. They're both half of the same angle. And that is a true statement here, and there's a theorem that goes along with it. If two inscribed angles, angle L and angle M, intercept the same arc, they both intercepted arc KN, then they are congruent. So if two inscribed angles of a circle, in this case we are talking about angle L and angle M, they intercepted the same arc, they both intercepted arc KN, yeah, then they have to be congruent. And those aren't the only arcs that I could draw. I mean, from KN, those aren't the only inscribed angles I could have. From arc KN, as long as I do two chords of the same point, and they go from K and N, that angle would also be 52 degrees, because it's another inscribed angle, endpoints are at the same intercepted arc, K and N. And you could draw an infinite number of those angles as well. So that's kind of neat. Let's look at an example of that. You notice in this picture, I'm not giving you any angle measures, I'm not giving you any arcs, but just from looking at the picture, we can name two pairs of congruent angles in this diagram. Because angles R, S, T, and U are all inscribed angles. And if they intercept the same arc, they have to be congruent. So if you think about it, there are actually two angles that intercept arc RS. There are two inscribed angles that intercept this arc here. And what are those two angles? Well, this intercepted arc, how about angle U? That's an inscribed angle for intercepted arc RS. And if I use those endpoints, how about angle T? That's another inscribed angle for arc RS. So I know that angle U would have to be congruent to angle T. They both have that same intercepted arc. And what about, there's one other arc I could talk about that's intercepted by two angles. What about arc UT? There are two inscribed angles for that one. How about angle R? That's an inscribed angle for arc UT. And how about angle S? That's another inscribed angle for arc UT, so I know that angle R has to be congruent to angle S. They're both inscribed for the same intercepted arc. Okay, so cool example where you can find congruent angles without even knowing any measures. If intercepted angles intercept the same arc, if inscribed angles intercept the same arc, they have to be congruent. And let's use everything we talked about to do a few more examples here. Let's find the measure of the arc or the angle. Find the measure of angle HGF. Angle HGF would be this measure right here. Well, wait a second here. If I look at that angle, its intercepted arc would be right here. I don't actually have the measure of the arc. Oh, but wait. This is 80 degrees, this arc. And I know I have a semicircle. This is a diameter because it goes through the center. This semicircle, then these two arcs add to 180 total. If this is 80, this has to be 100 so that this semicircle is 180. And now that we have an inscribed angle because the vertex is on the circle and we have its intercepted arc is 100 degrees, G would have to be half of that, or 50 degrees. And that looks about 50 degrees, so we're good. On this next one here, find the measure of arc TV, which would be here, this minor arc TV. Oh, stop that. This is an inscribed angle at angle U. Vertex is on the circle. Therefore, the arc has to be double that. So I'm doing 38 times 2 and getting 76 degrees for arc TV. Again, inscribed angle, half of the intercepted arc. Intercepted arc is double the inscribed angle. And in the last example here, find the measure of angle ZXW. ZXW, that is this angle right here. Now I could do this by doing a few steps, or I could do it the easy way. Notice here, the one angle I'm given must help me find this. So this is a 72 degree inscribed angle, vertex Y is on the circle. The intercepted arc is WZ for that angle. And doesn't angle X have the exact same intercepted arc? Now I know I could double angle Y to get 144 for arc WZ, and then I could take half of that to go back to angle X, but shouldn't it also be 72 degrees? Because I would just double 72 and I get 144 here, and then I would have to take half of 144, which is the intercepted arc for angle X, and get right back to 72 degrees. So that was the last thing we talked about. So today, talking about inscribed angles in circles being half of their intercepted arc.